Welcome everybody. This is our next video installment of our technical training, where we are going to dig into SvHCI, HCI being hyper-converged infrastructure. So for those old hands in the virtualization space, traditional virtualization was compute nodes and shared storage. And in the big data center, that was your big external SAN array, and then your compute blade infrastructure that was your compute. Great. Hyper-converged came along as a buzzy term because we all love that kind of stuff. And what we did was we internalized that storage within those virtualization nodes to build hyper-converged. Now, again, referencing technologies out there, that's VMware and vSAN. That's Nutanix and VMware, Nutanix and AHV. That's SimpliVity in VMware and various other things in this space. So rather than needing the big expensive external SAN for the edge, I mean, just referencing some of the senior HP reps I've gone and spoken to, nobody's deploying hardware SAN at the edge. Why would you? It's too big, it's too heavy, it's too expensive, etc. So hyper-converged infrastructure, using that internal storage to get the same benefits of virtualization without the need of that external array. Now, StorMagic has been doing that with SvSAN per our prior video for many, many years. Okay, we are, I would like to say, experts in this space as far as clustering and resiliency and edge. And we referenced a lot of the different architectures and environments and failure scenarios and extreme failure scenarios as far as Humvees and things like that in the last video, which you should have watched. And so what we did was to effectively come out with then a hyper-converged stack. So rather than just being the storage piece with SvSAN, which is a fantastic product and continuing to be developed, because fundamentally SvHCI and SvSAN are very tightly coupled, and you'll see as we work through this that they're effectively the same thing with a different sort of personality type on it, is how I'll phrase it. But it means that we have the option as a solution stack to be, a software SAN on your virtualization infrastructure of choice from VMware, Hyper-V, or Proxmox, to SvHCI, where we own the stack. And we're actually also in beta currently, and I'm sure with any luck it'll go GA as a hardware SAN as well. So SvSAN bare metal, whatever we call it, SPSAN, SvSAN, StorMagic Virtual SAN, StorMagic Physical SAN, SPSAN, just as an FYI. But within that same build image, being able to support hardware SAN, software-defined storage, and then hyper-converged infrastructure as well. So hopefully some pretty powerful stuff, but hyper-converged infrastructure being there on the slide, all about then owning that full stack versus being a piece of the puzzle with SvSAN. Anything you want to add there, Stuart?
No, that's good.
Perfect. Okay. So this is the same sort of deck as we used in the last video, and I want to sort of effectively skip over that marketing gumph, but once again, edge-focused software, great support feedback, a supported virtualization stack versus a open source approach, something that is tried, tested, secure, resilient, appropriate to the edge. Okay. Our previous deck, I think we had SvSAN, we had SvKMS featured in there, edge control, which we'll do another video on later on, SvKMS that we'll do another video on. And again, the powerful thing here is where we had SvSAN integrated with SvKMS, we also get that same integration with SvHCI as well, as we'll see. So again, infrastructure, we get some great verticals. We're appropriate to many verticals. I would say SvHCI is actually even more focused at edge today. Where SvSAN, we referenced in the last video about some use cases that are hundreds of terabytes and what else, 2 petabytes even, or whatever it might be. SvHCI is even more perhaps edge focused today. Again, as we develop and mature the product, it's going to scale to be able to support more VMs, more nodes, more things like that. But you'll see that this is, focused for now very much at solving the problems of our edge customers. Okay. So to give you an example, a lot of our customers say some 6,500 sites of 2-node VMware and SvSAN. Well, Broadcom and VMware have effectively turned the world upside down. And those customers came to us and went, hey, we love your storage product. Can you help us? Which is exactly what we did then with SvHCI. So this is just a reference then. I mean, it's a little bit about StorMagic as a whole, I suppose, about these changes in this space, opening everything up. Everybody's looking at their options. You know, when something as major as your virtualization stack that you've been dependent upon for 20 plus years causes you issues, I'll say it like that, you're absolutely going to be looking at, well, do I want to get in bed with another vendor? Do I want to go open source? Do I want to look at containers? Do I want to stick with VMs? Do I? What's my cost of entry point? What can I do? Do I need to refresh my hardware? You know, there are lots of solutions out there as alternatives, but they come tied into specific hardware choices and perhaps 2-node, 3-node, 4-node. There's all these different things. It opens everything up as a conversation. Okay. But I mean, as I say, open source, a lot of people are looking at KVM, but it always comes down to, with that sort of thing, well, who's going to support it? Who's going to, you know, be able to own and fix the code in these cases to know what you have? And do you have the expertise in-house? Do you depend on a third party to be able to do that? How do you go about that support piece? Because that's what matters. You know, when it's 3 o'clock in the morning and you're phoning somebody up, you want to be able to make sure that, you know, someone's actually able to help and deliver on what they're saying, I would propose. So we're here looking to effectively add that certainty. We've got experience in this space, and we think we've got a great product, you know, to be able to solve these problems, as we've referenced before. So as far as pillars and things goes, it's always good to have some pillars. You know, SvHCI is effectively following those same sort of mantras as SvSAN, just even more so to start with, at least. So, you know, that piece about right-sized, easy, simple, what I'll say here is a full stack solution is a user that already has experience within a VMware, within a Hyper-V. This is all going to be very, very familiar. Okay, it is not a complete rip and replace or new terminology or new experience or things like that. I'm hoping you'd agree, Stuart, that it's if you were using a third-party company to be able to support your infrastructure, for example, if they know VMware, they're going to be able to get on with this, you know, very easily and simply, I would propose.
Yes, I've demoed it to multiple customers, and they're pretty surprised at how easy it is compared to some of the other virtualization platforms and how it falls along with the same type of infrastructure for creating your virtual switches and things like that.
Well, that same sort of model is, you know, being able to get the virtualization piece up and running in what, even with install time, 30 minutes to get a cluster up and running. You know, then you're layering your applications, your VMs on top. You know, but that easy to deploy methodology is absolutely there. I'd argue perhaps maybe 30, 45, I'll be generous, as a non-automated install. And that's mainly down to copy time over ILOs, iDRACs, all that kind of stuff from ISOs and bits like that. But again, it can be even faster than that. This is my biggest point. Okay, so one of my reasons for personally pushing this as our own approach is, rather than coming out with something yesterday, KVM open source, well, I don't know what that is. I don't know how far it's come or when you cobbled it together, or, you know, how long have you cobbled these things together? How many releases have you done? How resilient is this thing? Well, actually, with SvHCI, as you'll see, it comes from all of that history of SvSAN. It's not something cobbled together yesterday. It is, as much as we've done, you know, where are we now? April 25, we've done 3 releases of this thing now. It is a extension of what we already had, versus saying, hey, look, we'll grab a Ubuntu, we'll grab a Debian, we'll integrate this from this open source repo, we'll integrate this clustering tech, we'll do this. What those open source tools do, don't get me wrong, they're fantastic, but they are externally owned. Okay, so they add their own caveats around clustering. One of the terms around there that you should hear is raft and 3-node and 2n+1 being a minimum requirements and things like that. They add complexities about how you consume that storage. Well, do you need a shared file system? Is it GFS2? What does that GFS2 do to your system? Does it have overhead? All right, I'm using Ceph. That requires 3-node. What does that do? How does that behave? All of these questions. What does that do to my performance that it opens up? Again, this is SvSAN block storage, fundamentally, giving you that resiliency, that extension of what we already had, rather than your sort of open source piece. And again, a lot of these environments that we work in the enterprise space aren't necessarily happy with, opening up their environments to open source repos. They want to be able to check those repos. They don't want to just do an apt update and suddenly get everything, and perhaps something's bad and not secure, or perhaps something breaks something else internally within that stack, or what it does. Again, who supports it, who owns it, those things matter. The other thing that I've gone and had is the religion that is in certain organizations as far as which Linux distribution. Oh, well, we qualify RHEL. We're only a RHEL shop. We don't touch anything else. We love Ubuntu. Ubuntu's our best friend. No, I don't like Ubuntu. I like Alma Linux because it opens everything up. Again, as an extension of SvSAN, we'll see that this fundamentally is StorMagic OS. It's still Linux. It's nothing complicated in there, but there is no external dependency. We own it. We support it. And if something's not right there, we fix it. So in an open source model, you're going out, you have to go to your maintainer. Is there even a maintainer? Can they make a modification? Does that then get accepted into the repos? It then gets out over to the public repos for you to then pull in out. It all just adds slowdown. To give a real world example of that, let's use something, one of the CVEs from a few years ago in the form of shell shock or heartbleed. We were releasing fixes for those things within a week, okay? Because again, it's our image and we simply ship an upgrade image. So really powerful stuff from this perspective, okay? And again, with that same thing, we are focused with SvHCI as it is today as a 2-node, and it's a maximum of 50 VMs today as well, okay? So this key piece is all about savings on hardware and software and being able to have that nice edge environment, for your systems. Anything else to add there, Stuart?
We do also offer a single node for customers that just need a server to do virtualization in remote locations where they don't have a lot. They just need a few little servers file and print and maybe a little application running, and they don't need HA. They just need the ability to have some type of virtualization. So this does give them the option for a single node.
Single node with fleet management, I propose, because you raise a pretty valid point, and single node that can be non-disruptively converted to a resilient 2-node topology as well.
Correct.
I agree with all of that. Thank you. So SvHCI. Now, again, virtualization, hyper-converged. It's typically been 3 nodes, 2 switches, and a SAN, or something heavier. The world got a bit smaller with the likes of hyper-converged technologies like SvSAN. What we've now done, as I say, is release SvHCI. Okay, so it's a full stack rather than StorMagic just being the storage in that puzzle, a piece of that puzzle. With this, we own that stack. We own the compute, we own the virtual networking, we own the virtualization, the clustering, the shared storage, the whole thing. Okay, so the nice thing there is it is lightweight and you have a single point of contact for the whole thing. Touching on that, we are also going to be doing OEM with certain vendors where we are actually first line on the hardware even as well, and can do a warm handoff up into that hardware vendor. So again, I don't want to dig into too much of that. I'm sure there'll be much more to come as to who those are and what those models look like and everything else. But even from a hardware perspective, single point of contact to be able to do hardware, virtualization, storage, the whole shebang. Okay, so really powerful from it's the nasty way of putting it. Single point, a single throat to choke, single point of contact, single thing to contact and own and support. And this being StorMagic Tech, the technical services team, we know it inside out, because again, it's all based on our history of SvSAN as well. So what we effectively did then, let's take a step back for a second, is turned on the virtualization in our build image, is how I would phrase it. Now, if I translate that into real world terminology, within a Windows machine, even your laptop, you can turn on Hyper-V and be able to have VMs sitting on your Windows laptop. You can do the same thing with VMware Workstation. You could do the same thing with VMware Fusion on a Mac. What else would be the other example? VirtualBox on a Linux. Being able to do virtualization on your machine. That's great. That gives you virtualization. What it doesn't give you is resiliency and high availability and live migrate or any of those things. Okay. We already had all of that from SvSAN. We already had the mirroring of the disks and the data and everything else. So what we've done is switch on the virtualization piece, and we've switched on the virtual networking. By saying that, as you'll see with the slides in a minute, we've integrated Open vSwitch, we've integrated QEMU KVM. So again, standard technologies. We haven't invented something out of thin air yesterday. Those standard open source technologies, but we've integrated them into the rest of that stack to be able to do the clustering. And it's the clustering that matters. Per our previous video, it's the clustering that enables all of those failure scenarios and everything else that we've been referencing. So it's that piece that is the real IP of what we have and what we do. And the virtualization sounds a little bit snooty. The virtualization piece is boring. It's not boring. It's just that you can do it completely for free with different technologies. With this, it's a supportable, powerful, performant virtualization stack. So we can see here then per SvSAN. In an SvSAN world, we phrased it as a MPIO disk device that we give to the hypervisor over iSCSI. Now, in a VMware world or a Hyper-V world, we would go, there you go, hypervisor, here's 20 terabytes. Stick a file system inside it, and all of the VMs are inside that blob on that file system. VMDKs, VHDs on that shared file system. Proprietary files, proprietary shared file system to be able to do all that stuff. Okay, let me be clear. StorMagic doesn't have a proprietary shared file system, nor are we leveraging an open source one like a lot of other people out there in the form of GFS2 or OCFS or some of the other things, because they add their own complications around quorum, their own overheads over the number of nodes that you need. We are using our disks, what was 20 terabytes, 200 terabytes. We've just then made them more granular, that disk becomes equivalent to the VMDK. And I'll show you that in a lot more detail with some real systems in just a second. But the powerful message here is, per my piece about I've turned the virtualization on, what we're also then doing is maintaining that synchronous copy of that data between those two systems, of those mirrored disks, those VM disks. So in a vSAN terminology world, that's a replication factor 2. But we also then maintain that internal resiliency within those systems. So we get that software RAID or hardware RAID, and then the replication factor 2 giving us that cross-node resiliency, internal node resiliency and cross-node resiliency, multiple fault domains within this little infrastructure. And I say little, could be an Apollo with 100 terabytes or whatever it might be, but you get the idea. Now, we referenced in the previous slides as well with SvSAN that you can then stretch these systems. We have many stretch cluster type use cases. Exactly the same thing holds true here with SvHCI. We can live migrate the VMs between over a stretch cluster. We can stretch that storage over a stretch cluster. And we are publishing various white papers on the topic of that with a bunch of data to be able to back that up. Okay, with some real tests, what we'll be doing is effectively WAN-M between to slow those down, to slow that traffic down for that live migrate to demonstrate then real world the impact of adding that latency on these systems, be it an impact to performance, be it a catastrophic failures of the cluster. At what point does latency have a line in the sand, big enough impact to the environment to go, no, it must sit beneath 20 milliseconds of latency, 30 milliseconds of latency, 10 milliseconds of latency, whatever it might be. Okay. Being that this is SvSAN, we also maintain with our IP, our clustering, our witness, all of that shared witness logic. So 3000 milliseconds of latency, 9 kilobits per second of bandwidth, and being able to do node, then witness failed and continue to run. So we maintain all of our key clustering and that lightweight shareable witness that can sit just about anywhere. We inherit optional SSD read-write, memory-based read caching, and per my statements about SVKMS, we inherit data at rest encryption as well. So let me just be clear. SvSAN is running StorMagic OS with our proprietary storage stack in a virtual machine as a storage controller virtual machine. What we are doing with SvHCI is putting that same StorMagic OS bare metal on the server, being able to then support the VMs, make them resilient, and make them fail over or able to fail over between these systems in the event of a issue, catastrophic server failure, all that good stuff. Anything to add there, Stuart? I don't think I've missed anything. But
yeah, just that we're installing SvSAN at the kernel level instead of writing as a VM on top of your hypervisor of choice.
Okay, so just to be clear, sorry, SvHCI at the kernel level on the hardware.
Correct.
SvSAN as a virtual machine on top of a
Correct.
virtualization layer. Exactly. Correct. That. Okay, so I think this probably emphasizes a bunch of stuff that we've just gone and referenced there, but just to double down on it, this is a full stack solution. So we're not talking a piece of the puzzle. Trusted hypervisor, KVM, QEMU KVM that we've integrated into our stack. Open vSwitch, advanced virtualized networking, virtualized storage, SvSAN. Internally, as an FYI, that application stack we call MIST. Just as think of it as an application running on there as a storage application. We ship it as an appliance, as that storage controller virtual machine as SvSAN. Now, what I'll just state here, storage virtualization based from SvSAN, the massively powerful thing of this versus some of the others. And again, I say some of the others, SvSAN on a hypervisor is a separate virtual machine on top of. So you've got a layer here as a virtualization layer, VMware, Hyper-V, an operating system of some form, Debian Linux, if we're sitting on top of KVM as a VM, for example. SvHCI, we don't need to do that. We are that layer, i.e. the virtualization layer and the storage are then side by side in that kernel. Okay, so for those that are familiar, this is SvSAN on VMware, one on top. This is Nutanix, a CVM on top of AHV or on top of VMware, SimpliVity on top of VMware. SvHCI is this, a la ESXi and vSAN, side by side in that kernel. So really powerful, really tightly integrated, fast, responsive. Yeah, just nice and tightly coupled to be able to provide a best of breed solution, I would propose, but unbiased. Extensive hypervisor storage integration experience. So I guess this just references StorMagic's history in this space, 15 years plus of knowing these customers, knowing these use cases, knowing these failure scenarios, and knowing exactly what we need to do there to be able to, provide what our customers are looking for. And per Stuart's statement, bare metal install. So rather than shipping a VM or installing a VM with an ISO, we are using that ISO and installing bare metal to the server through the ILO, through the iDRAC, through the XCC, through the SIMC, whatever it might be, to be able to get that up and running. And again, just to reference, our ISO, I'll show it, is about 300 megabytes. So an ESXi ISO, I think, is about 700 megabytes to date. Saying about the differences between open source approaches, a Ubuntu ISO, standard server ISO with 2404. Why don't we drop out? I'm curious now. Should have this already opened up. There we go. Ubuntu download server 3 gig is what they're referencing there. Let me just guarantee what I'm saying. In fact, let's prove it with pulling it off our website. So coming to our portal, downloads, SvHCI ISO installer, check the box and pull. 211 megabytes, that's zipped. I think actual ISO is slightly more, 300. And our firmware, our upgrade image, where we're that same dual boot model that you can revert back if you chose to, or et cetera, and a mutable boot disk, that firmware image is 160 megabytes versus 3 gigabytes. Now, I reference that because say you're in an edge scenario, you've had this cluster running out there, one of those servers dies and your server vendor replaces that box. Okay, I now want to do a reinstall, a remote reinstall of that node. Well, if I'm having to push 3 gig over my WAN, I'll go away, have my lunch break, have a cup of coffee, and come back in 3 hours, depending on the connectivity, versus pushing 300 meg, 250 meg over the wire to be able to get that guy booted, installing, and up and running and integrated non-disruptively into that cluster very quickly. It's powerful stuff. That's what we mean when we say edge. It does matter with those edge scenarios. It does need to be slimline. It does need to be lightweight. It has its impacts when you need it most to get it back protected as quickly and resilient, as easily as possible. Low barrier to entry. Yeah, there you go. That was well timed. All the same messaging as SvSAN. Okay, so it's all about then lightweight systems, lightweight ISO images, lightweight everything. And how can I phrase this? Simple is actually sometimes quite hard. Simple is a powerful thing, and I say that we're simple. I'm a very simple man, trust me. My missus will tell you the same thing. You want it to be simple when there's 6,000 of these things out there. You just want it to work. But simple to get there takes effort. It takes time. And with this, what we do is spend a lot of time. It adds value to be able to make it small such that when it matters to you, you can get it back resilient and protected. I think that's the piece that I want to emphasize here. But what this is basically stating is as much of the compute resources free for the guest VMs as possible. And it means that we can run on some really slim, small, edge-focused servers. So I'll show you some edge lines here. I'll show you, Stuart, if you don't mind, we might connect up to your microservers. There's HPE microservers. And I can show you some Simply NUC systems as well with the extreme edge Simply NUC stuff to show you quite how lightweight this stuff can work out. So this will just reference, compatibility. Fundamentally, we've got extensive drivers and, hardware available and supportable. You should just be able to take our ISO and install it on just about anything. We do have an HCL. You'll notice the wording on there basically says, anything off HCL, best effort. And again, 95% plus are going to work out of the box. Any bog standard server is going to work out of the box at the end of the day. So there is that HCL there, but it does mean that any Lenovo box, any HPE box will just work. We'll show you some edge lines. We showed you that we mentioned the Simply NUCs, the microservers, DL380, DL325, AMD, Intel. Take your pick. Fundamentally, it's a piece of hardware. Right-sized. I mean, this is just referencing some of what we've said, and again, it transposes across from the whole SvSAN piece. Is that flexibility to pull something off the shelf with some of these OEM deals, but also then say that's not appropriate. Well, I don't need 6 terabytes. I need 60 terabytes. Well, I just change the storage in the system to give me that 60 terabytes. Maybe I want it all flash. Maybe I don't. Maybe I want it hybrid. Same principle. I need 24 cores. I need 48 cores. Nice and simple. By the way, the licensing is really friendly on that point as well, because we don't license per CPU core. We're not there like certain other vendors saying minimum number of cores for a purchase, and thou shalt buy every core in a system even if you're not actually using it, so you can't turn it off and you're having to pay for it. All these different things. This is a really easy to work with licensing model, really easy to work with company from that perspective as well. So again, no vendor lock-in on that hardware piece, but we can do then OEM and first line support with certain vendors. OS choices, Windows, Linux. I mean, again, take your pick. I've had FreeBSD running absolutely fine, the likes of pfSense, OpenSense, all these different things. It's a Chemu VM at the end of the day. It's not a problem from that perspective. UEFI, legacy boot, multiple NICs, multiple disks, easy stuff. Minimal overheads, efficient and fast. This just references the integrated nature of the storage and the clustering. Okay. Depends on user experience, depends on many factors. A typical VMware failover, from my experience, can be anything up to 2.5 minutes for a VM to fail over across, because of path timeouts and things like that, multi-path, that sort of stuff involved. A Hyper-V Windows Server failover cluster failover can actually be anything up to 4 minutes for that HA event and that VM to come back. Proxmox, similar to VMware, it's about 2.5 minutes. This thing, and we'll do one as part of this video, it's about 30 seconds, 20 seconds even, depending on, saying that wriggle room. Because we have been doing storage and IOs and everything else, we've extended that same clustering to the VMs. And those timeouts, there is no path timeout that you have to worry about. So it's really fast and really efficient. Now, what that means from a supportability perspective is it's the same clustering from SvSAN, so you know that it's good. What it means from an application perspective is, in the event of an issue, that application is back available to the users, to the customer, to the application as soon as possible. So a faster failover time being less impact. So certainly don't mix and match CPU vendors, but there's no issue at all with, for example, a 2-node cluster being Intel's, a 2-node cluster being AMD's. We've got options with both. And obviously the powerful thing there with the core counts from AMD and things like that, what we are offering is a per node license. So some of those AMD CPUs become extremely cost effective when it comes to high core count and things like that, because you're just licensing a node with us as an FYI. Now, hyperconverged single node, this is exactly what Stuart was referencing here. Single node and the ability then to be able to add that node in later on. You can see 1.x, it's 50 VMs now. We're ever expanding those limits, and they'll get even higher as we introduce multi-node. And again, per the live migrate piece, once you've got that second node in place, you simply protect a VM. It's then mirrored and highly available. And obviously you can then live migrate between those systems as well, okay, giving you that two-node resiliency.
And I'll just say one difference between the two single nodes is that the single node non-upgradable to the cluster is one license fee, regardless of the amount of storage that you have in that server. And then the hyperconverged upgradable to a cluster has a license for SvHCI and then usable capacity similar to SvSAN in 2 terabytes, 6, 12, 24, 48, or unlimited.
Correct, Nick. So be advised, that's going to get simpler, I believe, coming up. The SvHCI licensing will be a capacity-based license in the same vein as an SvSAN moving forwards. So if you have any queries or questions there, please just contact a sales rep. They'll know it inside out. They'll know what the price lists are, be able to share them, etc., etc. But yeah. With that two-node, then I kind of referenced this with that hardware vendor shipping a new server to you. But say I want to do a bit of maintenance to a system, well, I can live migrate my VMs across. I down that node to be able to do my firmware upgrade to the hardware, for example, or to pull a disk out and swap it, or to add a memory DIMM, or do whatever I'm doing. I bring that node back in and I migrate that VM back across. So that's a planned maintenance, but it's exactly the same logic as I say, if you have a critical storage failure, that whole node goes. It's the same principle that you get that new hardware, you bring that hardware in, you replace the server, you bring it into the cluster, you protect the VMs, and you're back available again. And again, we'll have video resources in the online portal reviewing that and working through that workflow as well. So again, just doubling down on a bunch of the stuff that I've been saying, rock solid foundation, standard open source tech, but tightly integrated into the existing stack with the existing stack modules to be able to enable all of this functionality. So not cobbled together yesterday, not new, extension of what we already had, our existing clustering, our existing storage, and again, no shared file system complexity. That's why we can do the two-node. It is effectively the guest OS file system and block the whole way down. So it is nice and simple and performant as well. What else we got? This is about the architecture. It's the same architecture as SvSAN at the end of the day. It's a immutable boot disk that can be a single boot disk, a hardware RAID boot disk. We can even do a software RAID boot disk. You'll see that in a second with the SvHCI Simply NUC nodes. It's this RAM disk model, this immutable dual boot RAM disk model, such that you can revert back an image. So, say I've got some 2,000 locations to be able to update. Maybe I get through, 100 and I need a backup mechanism, or at least I need to be able to prove higher ups that I have a backup mechanism. You have the ability to be able to effectively grub bootloader, transition that boot image back to the prior version. Change block tracking with those resyncs. So a node goes away and comes back. It's a quick resynchronization of the changes rather than needing to do the entirety of the data set, as least impactful, minimal impactful on those virtual machines as possible. Quick resynchronizations wherever possible. Closed model. This one's up for debate. Right now, it is a appliance-based solution, is how I would phrase it, i.e. web GUI access only, API access only. Okay. Now, that's where we've come from with SvSAN, and it's because of the edge nature of where we sit. What you want there is pen testing, security testing. We do all that stuff internally with our own QA suites with each release. We also get third parties to actually pen test us as well. Think things there like Qualys, like Nessus, like those kind of technologies. Okay. Now that becomes relevant to the edge because the edge isn't the data center, and maybe you've got some bad actor, something trying to get inside your estate and ransomware you, or who knows what. Okay. Now that's as we are today. We do have what I would describe as a debug mode that's available to our technical services team to be able to unlock the box in those scenarios. Fair enough. I potentially see a future path where a customer enableable if that's a word, SSH option becomes added into the solution. But we'll see. The principle of having that locked down, whether it's turned onable or turned off, like it should be, is obviously all around security and ensuring that you can sleep at night as a sysadmin, knowing that somebody can't just SSH onto your box through, some user password that's available across your entire estate or something similar, that the environment is secure, which is obviously what matters to you. Again, based on SvSAN, we get diagnostic log bundles. So I reference this as an on-prem solution. We've said about closed environments or military use cases or who knows what else, they can simply send a log bundle where remote access might not be possible, and we can still look into it, troubleshoot it, determine a timeline of events, say, hey, look, this thing went down then, this NIC went down here, we can see this guy alerting that this card had an issue, or this thing, or this disk is seeing latency, or so on and so forth. Those log bundles being able to enable that remote closed system troubleshooting, and to that effect, then obviously these systems eventing and alerting through your mechanisms of choice to be able to support these things. Operating systems, fine, extensive operating system list. Networking, again, fundamentally a transition across of the SvSAN networking, that ability to support back-to-back, load balance across multiple interfaces, but also then switch those connections. So again, in the modern world, I'm seeing more 25 gig, 40 gig, do 25 gig back-to-back where you still have 1 gig front end. I don't care. It's just networking at the end of the day. So again, that flexibility to cherry pick, be it SFP plus, be it RJ45, be it whatever works for you. From a fleet management perspective, and we'll do a proper overview of this, we'll touch on it today, but a proper overview of this, edge control, providing centralized management, fleet management of this estate of SvSAN on hypervisors, but also then SvHCI nodes as well. And we'll show you that in action in just a second. But fleet management of that state from a GUI perspective with some nice little widgets on status and things like this, but also VM visibility, VM control as well. T-shirt size, again, very similar to an SvSAN message. I've referenced this a bit, but cluster quorum. So node fails. Say I then get a WAN blip while I'm on my single node and I'm waiting on that break fix from my hardware vendor. Makes no odds to me. I continue to run undisrupted. Really powerful stuff. That's the clustering that we enable, that we inherit from SvSAN with our StorMagic witness. The same witness then can be used for both SvSAN and a hypervisor as well as for StorMagic SvHCI. So really powerful, straightforward, that can run just about anywhere behind network address translation, GCP, AWS. It's just a witness service at the end of the day, but really powerful clustering and tried, tested, and proven clustering within all of those existing SvSAN customers. I think we dug into that quite a lot in the last one, Stuart, but anything to add?
No, nothing.
I mean, what have we got? Storage failure, we referenced that. Cluster down. What I'll do, perhaps, is just drop out for a second. This one here, if we come to our knowledge base, SvHCI, within here is an SvHCI evaluators guide. Okay, so this details out on some systems with some back-to-back networking, and we'll go back to those videos in a second. Oh, what am I doing? What's that about? Some nice tables that walk through different failure scenarios. So an SvHCI node offline, a HA event at the end of the day, production continues to be served by the surviving SvHCI node. SvHCI initiates the restart of protected guest VMs on the remaining SvHCI node. Guest VMs that were previously running on the surviving node continue uninterrupted. So all of those failure scenarios detailed out. And videos, these are taken from a webinar where we did this live in front of, I don't know how many hundred people that were on the webinar at the time. We did, as we can see, a HA failover. You've got the whole webinar there. You've got the individual HA failover, witness connectivity failure, storage failure, cluster down, all of those things demonstrated live on a webinar in front of 200 plus people. That's the confidence that we have in this technology stack. Okay. Anything else relevant in the slides? Example configs. This is the edge lines that I'll bring up in just a second. This is a software RAID 1 over a couple of M2 adapters and individual boot disk. VM snapshot. That's an interesting one. Let's just touch on this briefly. We can see here that with our SvHCI 2.x release, whatever it's going to be there in, there's virtual machine snapshot. So obviously, really commonly used tool for patching and maintenance of VMs. Make sure that they're all in a good spot before you then delete the snapshot having updated. We can see there what it does is take a snap. That snap is effectively mirrored and can then be merged back in to that virtual machine as and when you're ready. There could be 16 snaps on a VM, and you can select the pool that snapshot then goes onto as an FYI. So you can do it on a particular VM, disable them, take a non-protected, take a HA, viewing of a snapshot, increase the base disk, fine, roll back, revert, manual delete of a snapshot, edit snapshot names and descriptions, logging. This is quite a cool one. Those VM level snapshots can actually be exposed as a iSCSI disk to be pulled off somewhere else. So if you're interested in that as a sort of backup mechanism, you'll be able to do that stuff as well. Snapshot CPI script level support for SvHCI native backup. So again, snapshot being a powerful addition from a data protection perspective as that first iteration to be able to then integrate with our own sort of StorMagic backup mechanism as well. Inherit caching, inherit encryption, data rest encryption backed by StorMagic support that we get all of our nice stats and feedback and everything else against, and use cases across the board. So let's get real with some actual stuff, if that's okay, Stuart, unless you want to add anything while I just pull these systems up. Anything to add?
I was just going to say, when you're talking about the server configs and RAID controllers, so we do support RAID controllers or VROC. If you've got a system that's a low-end server with just a VROC in it, we support VROC. Or you can just present the drives to us and we can do software RAID with our software. So it gives you a lot of flexibility, because when you're looking at a bunch of remote locations, being able to save that cost of a RAID controller for those configurations impacts your bottom line when you're looking at doing these type of rollouts to multiple, edge type locations.
Perfect stuff. Okay, so we used this same environment in our prior video, SvSAN on VMware. And the reason that I've brought this up is to go SvSAN on VMware. Here's SvHCI. Fundamentally, look, it's the same thing with some extensions. Extra bells and whistles is how I like to phrase it. If we have a look at this guy here, we can see our console of SvSAN. We can see StorMagic SvSAN on the top left. We can see our web GUI here. Think that ESXi host client equivalent on our VSA, StorMagic SvSAN. Nice and straightforward. We come to some real systems. Let's go to the ILO first. Forgive me that these are some older hardware. We'll dip around between some different stuff, but it doesn't really make much odds to me as far as a generation. Admin. We log in here and pull up the ILO. I get that same sort of DCUI-like console interface, curses GUI, whatever you want to call it, on the system on that same node. It's exactly the same thing. StorMagic SvHCI versus SvSAN. Okay. What we actually see then is some additional menu options in here. So now we see virtual switches and port groups. On this guy, I go network interfaces, network devices. This guy, network interfaces, I got virtual switches and port groups between, but I still get all the same sort of stuff that I can select my key map, I can upgrade, I can set passwords, I can do all that good stuff. And say I configured this in my lab environment or something, and I wanted to change which NIC was used on which vSwitch, I can swap it here. I can re-IP the system I'm looking to have deployed in one environment, ship it to site, and re-IP it via the ILO or something similar. Again, console, simple ability, not command line that somebody having to come in and modify NetPlan or NMCLI this or Network Manager that, or all these different things that using those standard open source tools. GUI-based, familiar networking stack, familiar GUIs, VMware-like interface to be able to get these things up and running. Coming back here just to show it, under this, the install piece, and again, this is like installation, console usage, boot wizard. It's a walkthrough of an install as these slightly different methodologies, but you can see here then with all of these, our install is there's an end-to-end install video. We select our ILO, we select what we're installing, and then with a very straightforward wizard, selecting to install SvHCI, which device I'm going to install it onto. The NS204 boot disks in this server, and I've got then, what's that, about 7 terabytes of RAID storage in that box. Okay, which NIC am I going to put it on? Well, my management interface is on a 1 gig. Fine, I want that NIC there, right? NIC 5. What IP am I setting on it as my management interface or DHCP? What subnet? What gateway? What VLAN tag? It's nothing complicated here, guys. It's all straightforward stuff to be able to get up and running, and in this instance, install onto that NS204 really quickly and easily, and obviously then coming up with that boot IP, and then being able to connect to it. And again, say I typoed something, obviously via that console, I could always come in and modify quickly and easily without having to command line on or anything else. It's just simple and straightforward and easy to use. So, per that point, if we now hook up to the web interface of this node, we can see here StorMagic SvHCI, StorMagic, where was my tab? StorMagic SvSAN, StorMagic SvHCI. It is SvSAN with some extra stuff turned on within it that we then get, you know, the extra bells and whistles of the compute virtualization and the clustering. I get the same menu structure. I get the same firmware image push, the same diagnostics, the same everything else. I just get some extra bits with SvHCI. Under my network tab, I can create a vSwitch. I can create my port groups. So again, I'm referencing here that it's a build process that's very similar to a VMware-like experience. I install, I connect up, I configure up some virtual networking, I can team NICs together with those vSwitches. I can do NIC teaming within that layer. I can configure up my interfaces. My interfaces are akin to my VM kernel adapter in a VMware. And I have flags that I can set on those interfaces, similarly to a vMotion, to a whatever. We can see that I've got a management, I've got a mirror failover, I've got a storage, I've got a whatever. And with my port groups, I'm simply creating port groups that I can then add my VLAN tagging against for micro-segmentation and logical separation of applications and VM workloads. Anything to add there, Stuart?
No, it's pretty simple. When we do our networking, it's similar to the same process you would do within VMware. Set up your virtual switch, set up your interface, and then add your port group. So similar process as you would follow within VMware.
Agreed. My next step would be to take a look at my pools, perhaps, how the storage is being leveraged in the server. Now, I referenced with that slide, this is a single 512 gig boot disk that we can see here. And we can also see, just to emphasize my point, in the ILO, if I select storage, we can see I've got a 4 terabyte, a 4 terabyte, and a 512 gig. I have my 512 gig as a boot, and per Stuart's feedback there about software RAID, we're effectively using Linux MD. We could then do a software RAID 1 over those two 4 terabytes, 3.5 terabytes to provide some resilient SAN storage internal to the system for my guest VMs to sit on. Okay. Now,
and we can do RAID 0, 1, or 10 software RAID.
Agreed, which we can see there. Thank you, Stuart. Appreciate it. I referenced before about in a SvSAN and virtualization stack world that I would go, here you go, have a blob of storage, VMware, have a blob of storage, Hyper-V and Windows Server failover clustering. With that, from StorMagic's perspective, we're stuck behind that shared file system. We can't see the individual VM disks. We are just a blob of storage. We don't know what's inside it, as it were, being a block device. The nice thing about this is the pool becomes akin to the VMFS. What was the StorMagic disk, the 20 terabytes, the 200 terabytes, is now significantly more granular, and we can see it's 60 gig, it's 100 gig, it's 200 gig, it's whatever the disk is. So what was my blob of storage now becomes akin to the VMDK, the virtual hard disk. Now, that doesn't seem like that much. From somebody that's worked with SvSAN for years and I've been stuck behind that file system for a long time, this is really exciting. And it's exciting because suddenly I'm in a world where I get the disk. And it means that when we select one of these virtual machines and we choose to snapshot that virtual machine, well, I get the disk rather than it being a snap of 20 terabytes and it's an all or nothing restore and a recover and a resignature of a VMFS and all of those different things. I get the disk. I get the guest VM disk. And it means that when we take that disk and do a snap off to something else and copy that somewhere else for a backup and all of those different things, I'm that bit more granular. So suddenly I'm in a world where I can do, if we wanted to do edge to center, copy that up to some other location, some data center, rather than needing to do 200 terabytes or 20 terabytes. Well, I just want that one VM disk. That's my important one. Suddenly I can take 60 gig and take the deltas off to my other location. Suddenly, with this more granular architecture, it opens everything up from that perspective. So it's powerful stuff, and it's going to enable us to add significant functionality and stuff as we move forward as well, we propose. So having configured the storage in the system, we can then cluster the nodes themselves. So we can see under my discovery page, I've got node 1, I've got node 2, and I have my StorMagic witness, the same witness from SvSAN. I can edit that cluster. I can split that cluster apart. So non-disruptively, I can choose to remove a node, unprotect VMs, do all that good stuff to be able to take a node out, bring it back in, undisrupted, non-disruptively, like I referenced before. Again, all of that documented. So what have we got? That one was installation. We've got a first boot wizard where you're effectively connecting up and licensing the box. We've got then configuring up the networking. Forgive me as we sort of work our way through. We can see with this screenshot here, that same DL325, I've got the 1 gigs here, and I've got some 10 gigs there. And what I'm going to do is with this LAN vSwitch here, I'm going to do some NIC teaming on that LAN vSwitch for my management and add some different VLAN tags. And then on my vSwitches, I'm going to do some back-to-back with those 100 gig Mellanox NICs that I've got in place there. Lovely, lovely. Yes, please. To be able to load balance and failover between those multiple NICs as well. So interface configuration, creating interfaces, fine. Existing management, storage interface, host configuration, blah. So we've done our virtual networking. We cluster the nodes together per the prior statement here. Join, point it at those 2 nodes in the witness. There's no, oh, I need to copy this certificate and this thing over here and this thing over there. They know what they are. They're communicating over dedicated proprietary services and things like this. They use our own custom registered port as an FYI. TCP, I can't remember. I was going to flash something up for a second. TCP port register. This must have been me. IANA, that's it. To show something of interest. Let's go StorMagic. Within here, there is our StorMagic services that have been registered with us since 2011 as to how all of this stuff communicates. So like port, forgive me, 22 is SSH. I'm showing my, what would be SMTP, Stuart, off the top, like 443 is HTTPS. This is our port. Exactly, that would be another example. So clustering them together, you're not having to kind of copy things around. You literally go join that node, and there they are working in a nice healthy state. I'm aware that mine are in sort of different error states. Apologies. Configure your storage pool, license your pool, and then you can create your VMs. It's all standard type stuff. So creating of virtual machines is again, VMware-like process. Protected is highly available and mirrored. PV-SCSI, VirtIO, Legacy UEFI, add NICs. We've got, what have we got? VMXNet 3, E1000. This covers all modern operating systems, by the way. Add disks, add as many disks as you like, etc., etc. It's a virtual machine. At the end of the day, you can get it up and running very, very quickly. So if we look at these guys here, we can select them. They're all on node 2 at the moment. Let's migrate one over here. So a live migrate of that guest, we can select that guy, we can edit that VM, we can take a snap of that VM, snapshot usage, We can see it's got an ISO attached in the form of the Ubuntu ISO. Because it's protected, that ISO also needs to be mirrored. You can see a nice little graphic as it live migrates that guest VM across. We also are imminently to have a VM import tool as an FYI to be able to stream VMs across from a VMware. So the powerful thing there being point it at your host, point it at your vCenter. I want that VM. It's streaming the I/O in, recreate the VM with the same MAC address, the same data, the same everything else to power up on our side. So powerful stuff. We can see here standard VNC-like interface in, but all nice and secure because it's through our own GUIs. And we can edit these things and, as I say, modify its add NICs, modify its port group that it's attached to, all of those good things you'd expect from a virtualization solution at the end of the day. As an FYI, the reason that this thing, if we have a look at this error, is in an error state, forgive me if I left click there, we'll see it's because I've imported this VM across from VMware, and I didn't have a port group with the same name on this host as I do within VMware, so I simply edit here, switch it to a port group that I want it on, LAN, apply. That then goes to a nice, healthy, normal state. I power it on. Can I? And we can then see that VM coming up on SvHCI as a Windows guest that was imported across. And as we can see, that same VMware MAC address, such that it's not having to relearn MAC addresses, but actually alternatively, I could power it off and modify that MAC if I chose to as well.
And you can do up to 4 virtual networks per VM and 4 virtual disks.
It's going to be more disks moving forwards as well, by the way. That 4 is a 1.3 limit. I think it's going to 8.
8, yeah, 8 on 2.0.
There you go. See, there's lots of things moving at the moment. If anybody has any queries or concerns over that stuff, look, engage us. This thing is more than capable, I would propose at the moment, but any queries, concerns over maximum sizings, anything like that, give us a shout. As we've referenced, today it's focused at about 50 VMs as maximums. Now that's, I would argue, more than enough for most edge use cases, more than enough for most 2-node use cases. But again, maybe not. If you've got those odd use cases, do get in touch. Those numbers will be increased, those limits will be increased, and we are going to be going to a multi-node scale out, et cetera, as well. So yeah, do please don't discount it straight off the bat just because of some of those maximums. Do come and talk to us, would be my proposal there. Within here, within that console, you've obviously got standard no VNC, so we can come in and hand in a Control-Alt-Delete to be able to then log into the machine, etc., change its IP address if we chose to, do whatever we're doing there. It's bog standard VMware and bog standard virtualization, I should say. Again, being based off of SvSAN, we get all the same eventing and alerting. And let's just hook up to, forgive me, if I go to the
1050.0.
All right, let's do yours first. Forgive me. Good shout. From then 10.50.0.103.
103 is the ILO, and 105 and 106 are the SvHCI.
So we can see here an ILO 6 just to show it running on something not an ILO 4. Good job I remember those credentials, Stuart. Otherwise we'd be sending them live on the video recording for the world to hear. Where are we? HTML5 remote console. Go. There we go. Exactly the same principle. Let's make that big and bigify that. But you get the idea. It's the same concept. It's the same stuff. So we could, for example, come in there. I don't want to do that. I was going to show there. Oh, add a NIC. What have you got? You're likely to have that as a password. And vSwitch. Good question. Devices. No. Okay. So we've got all our good stuff there from a scaling thing. So we've got our node there on a HPE microserver. So saying about sizes of environments and such like. This thing. What are these? They're quite nifty and little, aren't they? But they're like 8 threads.
8 threads, yeah. 8 cores.
64 gig. Yeah, 64 gig of memory. Quad port 1 gig NIC. You've got 2 of them. You've got 8 NICs there to play with. Very nice. Device inventory. These are the VROCs. Just out of curiosity, Stuart.
Right. They have VROC. They have VROC in them. They have a 480 gig boot drive, and then two 3.9 terabyte SSD or drives for capacity.
So just to demonstrate them, and forgive us that this is looping around a little bit. 10, 50, 0, 105, 105, go. We have a look see here. If I go to pools, okay, this guy's software RAID. The other guy is perhaps VROC configured, Stuart? Or are they both software RAID at the moment?
I think these are both software RAID. The Gen 10s are VROC.
Okay, could I have a Gen 10 just to flash that up?
Yeah, it's it's 3.3 and then .5 for the SvHCI.
There's nothing like doing it live. Thank you, Stuart. There we go. So we can see here then about that VROC piece. So for those that aren't aware, you've got hardware RAID, you've got software RAID. VROC's a slight sort of hybrid between the two. And what it allows is on chip, that ROC RAID on chip. For that RAID to be happening in there. It's kind of an extension of Linux MD to a certain extent, but we can then consume a VROC disk, as we can see here. So this is a RAID 1. We still get to see those individual drives. It appears in our interface, but it's VROC that's actually then managing and owning those drives in that scenario. You'd agree with that, Stuart, if I phrased that okay?
Yes, that's correct.
And then finally, just to show about the Extreme Edge, the Simply NUC systems. Those are those ones. 21, 22, I'd argue that it should be that then. Send it back credentials. System, that's one of the 3Ks. So if I have a look at this thing, that's an individual disk. 10.40.0.33 then. 13. At least you knew your IPs, Stuart. You were more organized than I am. So this guy, as we'll see then, is one of their 2Ks. So the only reason that I'm referencing this guy, and let's just show here that piece about those VM disks, so ISOs versus VM disks, virtual machines. Fine. And if we have a look at pools, the reason I wanted to bring this up, we can see here, if I select this boot pool, another box, RAID boot, that's what I wanted as a screenshot. There we go. So this, during the install process, these systems have just the two M2 adapters inside them. They're really small. And what we've done with these during that install is make a bootable software RAID 1 over those systems as well. So we can do software RAID across external, if there's separate boot storage, but also the boot storage. So if we just reference these things here, Extreme Edge, Simply NUC. These things are some fanless, they're these things here. They're completely fanless. Two M2 adapters inside. You can see that you've got some M2s, you've got some management NICs, you've got a BMC interface to be able to remotely manage the hardware. And these ones are, what are they? 8 cores, 16 threads, and I got 64 gig of memory. They can go up to 96, etc., etc. That's selling hardware at this point, but you get the idea. Is from a software perspective, we can run the gambit between something as small as this all the way up to the DL325, the DL380, the big beefy servers and more capacity and everything else. So SvHCI, powerful, resilient, rah, and final step, I would argue. Let me come here. I want to select this guy, and we're going to do it and do it live. I'm going to edit this guy. I'm going to protect this guy. Edit that. I'm going to select my remote pool as that one there. Accept. It's 150 gig. That's fairly challenging. Fine. And what I'm then going to do is hook up to 10.10.1.4. So this guy here. That'll be mirroring here. I can mouse over this. See that? I can mouse over this and get a resynchronizing. There it is, about 600 megabytes per second in that example. Fine. I want to, I have close to VNC to it, typically enough. Command. Nope. Don't trust me to try, Stuart. What am I doing? Command from my client. Where's this guy? 10.10.194.43-T. Do it and do it live. I will highly recommend it across the board. Oh, biscuits. Says the man that watches too much Bluey with a 5-year-old. There we go. Getting some pings back from a VM on 43. Agreed. So we have our VM running on this guy here. It's currently synchronizing that disk. And what I'm going to do is kick a live migrate. And again, we'll get this nice visual in just a second as it does that migrate across over to edge line 2. So again, this is just a proof point of a vMotion of a live migrate equivalent. And what we'll then do is a HA. I'm going to kill host 2 and trigger a HA event, as it were. Just come here. One thing at a time, Mark. There we go. I should have been more organized, Stuart. I should have had it there protected and ready, but I suppose at least we've managed to, showing that conversion of a protected to typical enough.
Still quicker than VMware or Hyper-V.
Shh. We applaud our competition all day long. What would I say as caveats? Saying that, let's come along and talk about perhaps some of our gaps to date. So you can see there on this Windows machine a storage controller of PV-SCSI. Note that anything in VMware that was created as a Windows machine will typically have been created by VMware as using an LSI Logic SAS controller. So you do need to, before you use our import tool, get that booting off of a PV-SCSI controller, a power virtualized SCSI. We've got documentation on that effect. It's all straightforward stuff, but just note that you need the VM on a virtual storage controller that will then work our side as well. Referencing a bigger gap, this thing 2-node only today. Absolutely, we're grand visions and everything else. VMs only today. Grand visions are multi-node. Our containers, integrated bare metal containers alongside VMs on the same solution stack. So the concept there of dual modality, being able to do VMs or containers, that's a longer term vision, but it's absolutely there as a direction that we're going. Other gaps then, backup integrations. That's the big one. I would argue with a lot of these things is a Commvault versus a Veeam versus whatever backup technology you're looking to leverage. They are not integrated with ourselves. We will have our snapshot API, public ASAP for those guys to consume. There we go. You'll note there with that single packet drop, I'm connected into over a VPN, but a packet drop is that VM live migrated across. But those guys are not integrated with us. We need them to be able to move and consume our snapshot API to be able to do their backups. In the meantime, you can use agents within guests, not an issue at all. We've got various bits of documentation on that around Veeam and how easy that is to do. It is pretty straightforward, I have to admit. We will also be offering our own StorMagic backup, sort of basic schedulable, copies of our snaps and disks off somewhere else as well. So we'll be offering our own sort of backup option as a shorter term future. as an alternative to those things as well. Any other gaps that are worth calling out, Stuart?
No, I think that's about it.
Saying about gaps, saying about things that we then do have. Edge control from a fleet management perspective. Now I'm already logged in here. This thing is multi-factor authentication and everything else, but we can see here under my systems tab, and we'll do this in a lot more detail as a separate video, but my SvHCI and BSAs and my edge lines that we can see here as well. You know, selecting those nodes, getting visibility into what they're clustered with, what firmware they're using, and being able to then see if I select here, 5 VMs on node 2, including that MC Supermicro remote that I've just gone and done, and I can power it off, I can reset it, I can do whatever I'm doing with that PM there. So here I am just going to power this guy off, power, press and hold, and that is then going to be, boom, I do like to give my big flick moment. And what we'll see this side is looking at the console of this thing, that this will have been posting various events on the console. You can see here, system abnormal state, there we go. Connection to node edge line was established. There you go, various events and things going on here. And if we have a look here at our virtual machines view and our pings, oh, I didn't even catch it, Stuart. I should have been more prepared. But you can see those pings coming back from 43 with that machine then running on host 1. We can VNC to this guy and see it then up and running from host 1. There we go. What did we drop? 1, 2, 3, 4, 5, 6, 7 packet drops before it was back responding on host 1 in the event of that HA failover. So if we have a look at this thing here, we can see them all nice and green on host 1. And if I take a look at the storage, we'll see that those different disks effectively, you know, in their different states based on the fact of, you know, amount of IO change that's gone on or whatever else on those VMs. Okay, HA event, SvHCI overview. Anything to add, Stuart?
No, just that we've got some upcoming videos with SVKMS and edge control.
Perfect stuff. Okay, so once again, thank you so much for viewing, everybody. Thank you for keeping me company, Stuart. Really appreciate it. And that support portal and everything else available, the trial on the other side of these videos, you know, we'll be requesting you register for a trial, spin up the technology, get hands-on with it yourself so you feel nice and confident with it. And we're here to help as well. So support app, pre-sales app, here to help. Thank you so much. Appreciate it. Take care. Okay. Done and done. Hour and 20. So it was like